Our next keynote speaker is Al Kapoor, the Chairman of Syntec Optics, a company employing over 300 skilled professionals. Headquartered in Rochester, New York, they specialize in the production of high-precision optical components critical to many sectors, including defense, medical devices, and telecommunications. Al Kapoor has over 25 years' experience in the optics industry. He's been instrumental in building Syntec Optics into the largest independent custom manufacturer of polymer optics in the United States. Under his guidance, Syntec Optics continues to push the boundaries of what's possible in photonics and optics. In addition, Al is the co-founder of the end-to-end PIC design company, Spark Photonics, near Boston, and on the board of their educational foundation.
Good morning. I don't know if I can match Jose's energy, but I'll try to, right? So, photonics evolution, that's a big topic, and we've been talking about it since yesterday. So, when I was approached about this talk, the question was, can this be more like a TED Talk? And we talk about the future in a more sort of way where it's more inspiring. We talk about our contributions because there are experts in this room. And I'm going to talk about a lot of topics where I may have to ask you to help because there's just so much there in photonics, and you'll see the scope of it and the diversity of it, hopefully. And so I titled this talk, Questions Worth Answering, just like TED, which is Ideas Worth Spreading. So the questions to think about, is light everywhere, right? Reinhardt mentioned that as well yesterday. How far have we come in our contributions? Will this growth continue? Will there be opportunities for all of us to keep investing, if you're an investor, to continue to be an entrepreneur like I am, or big companies that have emerged already, and how do they continue? And then one really important thing, an observation that we all have, and I'm just going to make it more obvious here, is that our contributions contribute to this larger advancement of technology, and I'll show you that. So let's get started. So when I finished school at Harvard Business School, before that I was an engineer and graduate school for many years, I tell my kids, you don't need that much education, but maybe if you're in photonics, you might. And at that time, I would go and talk to investors about a plan and say, photonics, optics and photonics will be everywhere, and they'll say, well, okay, we have fiber optics. Kodak had their printers and point-and-shoot cameras going away. What could be more? And I said, there'll be defense, there'll be biomedical, lots of other things. And here we are now. There are almost 10 end markets, all of them multi-billion-dollar markets. So these are great end markets. Any one of these you can touch can build a good company. And the other interesting thing is that companies we don't even think about are optics companies and photonics companies are, right? You have Amazon with their data computing centers, Apple, Google with their AR, VR, and their phones. We buy the next phone because there's that next technology camera. Facebook, of course, they talk about AR, VR, and the future of that. And of course, the likes of SpaceX and everybody who's entered with satellite communications. So where are we going? Where are we right now? So if you think about human needs, right, they're still the same. 1,000 years ago, 5,000 years ago, we still have the same human needs. We've just offered products over time that have become more effective and efficient. And we continue to do that. And light-based products are even further enabling this. And you can take the very primal needs like food, clothing, housing. We've been scanning things for a long time. There was someone who came to my house the other day, and he's got a laser, and he's measuring everything. I'm like, wow, you're measuring everything with a laser? He said, yeah, it's 1/10 of a foot accurate. So we've been talking about great accuracies in our companies and nanometers, but these products are everywhere and lots of companies involved in them. And then you've got communication. We talked a lot about that, 400, 800G. The AR, VR sets are out for gaming and other things, a range of things. Security. I'm hoping we'll talk more about that today. It was touched on yesterday a little bit, but we have these day and night scopes. We're aiming, marking, tracking. The world isn't becoming a more secure place as we thought it was going to at many times. And then there are all of these other needs. Transportation, we get in our car, you look at your dashboard, a lot of it is optics. That was a big thing 20 years ago. Now we have cameras all over the cars, and we're talking about even more things as we go. Healthcare, great space. Non-invasive surgeries, imaging, detecting, measuring. We're doing a lot of that. Solar, we're doing solar cells. And finance, of course, we offer security and biometrics and other ways. So almost every need is being touched by light-enabled products. Will this continue, right? So I was talking about Harvard Business School. We talk about industry forces and Michael Porter's 5 forces. But here, I've been here 25 years in this industry. It's been early, and I have always thought about a different set of forces, societal forces. Is there enough scientific discovery going on? Is there enough technology creation? Are there enough patents? What's the business environment like? Where's the government policy? And even social movement. So, as Jose mentioned, in Boston, I have a spin out from MIT called Spark Photonics with Kevin Macomber. And, we've been benefited from the CHIP Acts, where finally money is reaching companies that are even in earlier stage. And there was just an announcement of $9 million to BAE Consortium, which Spark Photonics is part of. So the benefits are coming from the government programs. As he mentioned, I'm on the board of a nonprofit, and what we're doing is we're taking education to high school students and talking to them about photonics, so they know a lot about electronics and they hear more about electronics, and in the same breath, we also talk about photonics to them and photonics integrated circuits that are coming in the future, so when they grow up, they're aware and they might pick this as a profession. The business environment, all these things are right now advantageously positioned for the photonics industry, and therefore I believe the growth will just continue. There are patents, laser patents, discrete optics is a big part of it now. Business environment, you hear about that from McKinsey. There's a long tail, a lot of smaller companies, a few big companies. So the consolidation will continue to have economies of scale and scope. And then with these social movements and government policies and continued scientific discoveries, this will all propel optics and photonics to continue to thrive. So where do we go from here? Well, there's a lot to do, right? Where do we hitch our wagons to? And there's a future in health, advanced 4D multiplane imaging and automation, DNA editing, organ printing. Security will be connected with a connected battlefield with AI. So we're already hearing about that, already contributing to programs where there are these scopes, and you can connect the scopes to all the other equipment, and that equipment could be on the ground in infantry, or it could be in the helicopters, or it could be in airplanes, and all of these we will be able to see, our soldiers will be able to see almost everything that other people are seeing in the battlefield and will be coordinating with each other. And once AI gets layered on that hardware, they will have even more prompts and other things to how to defend our country and be away from harm's way. Of course, we're talking about autonomous cars. They will continue to get more and more autonomous. There'll be cameras, potentially LiDAR detectors. We talked about energy. We talked about laser fusion. Solar cells will become even more efficient. Everything that's probably on the outside could give us more energy. And also, like we were talking about yesterday, why get the energy from the sun when you can have your own sun? So How far these things are, we will know, but there's a lot to do. Now, this to me was very interesting that, when you turn on the TV, right? CNBC, Fox News, Bloomberg in the US, and they talk a lot about the technology frontier, and there are investors who want to participate in this technology frontier because it's amazing, and it'll be something that will create more employment, will create more returns on investment. The interesting part is that each and everything that's at the frontier, that comes from the McKinsey article, is actually enabled by optics and photonics. So underneath all of that, there's a lot of optics and photonics that we're doing that's enabling these things. And if you invest and participate in building optics and photonics, you can contribute to all of these technologies in the future, and you can be sure that there are other fields, and it's just our field will continue to stay vibrant for a long time. So 20 years ago, I had a magazine that I was an editor and founder of called Innovate, and I interviewed a really interesting person named Al Chandler, who was a Pulitzer Prize winner, and who brought us these concepts of visible hand and economies of scale, economies of scope. And he was sipping his glass of sherry, and he told me at his apartment overlooking the Charles River in Cambridge, he said, "Hey, why don't you follow a science and technology that is not petering out," right? So he was writing a book at that time. He was quite old by that time, but he still was finishing up a book, and he gave me a copy of his early release, and he said that would lead to success. So at that point as an entrepreneur, I kind of shifted gears from mechanical, automotive, and engineering things I was involved in prior to business school, and even sort of some of the chemical aspects of it. And then I got into optics and photonics. And to me, that was a great field, right? And then over time, I realized in optics and photonics that it truly was vibrant. There was so much more to come, and there's so much more to come in the future and participate in. So if you think about it, it's like, if you understand American baseball, you're probably in the 4th innings, perhaps in a 9 innings, or even an extended game. And we're all very fortunate to be here and part of this, and appreciate what Jose and his team has put together. So let's imagine this future, right? Say you're a doctor. You wake up in the morning, you check the weather, potentially coming on quantum-based computing forecasts, much more accurate by the region, by the minute, and you leave for work in a driverless car. When you're in the car, you FaceTime your kids who might be away with real holographic presence. So this is the future, right? So not just any AR, VR glasses, but more immersive, the presence that Mark Zuckerberg talks about. And then you arrive at the office, and you're streaming terabit internet and exchanging 4D multiplane images of surgery, printing organs, get live AI feedback for decision making. Your office is, very solar enabled for all its exteriors. And then you have economic transactions that are safeguarded by quantum cryptography. And then you eat your lunch, and you know really what you're putting in your body because you can scan it and sense what you're eating. You have wearables that can tell you your heart condition, even glucose levels. And then you head back home, which could even be 3D printed. So optics and photonics in the future could potentially be every bit part of your lifestyle. And this is the technology frontier. So thank you again for having this opportunity, but we are in a great place with great opportunity, and I'm super excited every morning when I wake up. Thank you.
Thank you very much for a great presentation. The floor is, of course, open for questions, comments, suggestions, room for collaboration. Any questions in the room? For me, the most important question is, of course, when we have this Global Photonics Economic Forum in 5 years, What is your preferred future? What would you like the industry to look like then?
In 5 years? So, to me, it just seems like things just kind of creep up. Okay, like just the phone, the iPhone, right? I mean, we had the Nokia phone, we were happy with that, and we had the BlackBerry. I was like, held on to the BlackBerry way too long. And I mean, I remember doing camera phones for Samsung in 2005 and for Zeiss that were in the Nokia phone. And then all of a sudden, you know, the iPhone showed up and it just changed everything. And now you go back and you can look at some of the movies that are out. It was a process. They had the vision of iPhone, but they weren't able to put it all together that, you know, Steve Jobs did eventually. So it just sort of like happens much slowly, but then it just happens. ChatGPT happened last year, and all of a sudden, everybody's talking about AI. We were talking about AI and robotics back in 1989. So, you know, it'll just little by little we'll move forward. Not all these transformations will be there. We will have some advancements in quantum computing. Are we going to go from 400 qubits to, you know, maybe more? Will we get to 1 million? No. Will we be able to break all of the security codes? No. But then the security codes are getting better, right? Will we have more distance where we can move the photons for security? Yes, for quantum encryptions. So every field, like some of those fields are farther away. And other fields, connected battlefield and defense, where I spend a lot of time, we will not fully be there, but now we can look around the corners. The soldiers can communicate with each other. The scopes are going to get better. They're going to get lighter. And then, you know, in 5 years, we're going to get really, really close to much more communication.
We got it this morning with not the most positive news. There's a lot of things happening in the world. We're going to have lots of discussions today about that, what you said, about the concept of dual-use technology and if it's a reference for our world. What is your take? Does dual-use technology really exist?
I mean, I would like to seek people's feedback. I mean, there are a lot of experts here on a topic like that. And anybody would like to contribute to that?
Why don't we go to...
Who's the expert in dual use?
Why don't we go to Michael Hochberg? He's at the end of the room. Michael, you're there and you're mic'd up, so you can already speak. Does dual technology really exist? Dual-use technology really exist?
Short answer, no.
Yes.
I mean, the concept of dual use comes out of this idea that you can distinguish the intended use of a piece of technology ab initio before you export it. And there are cases where you can do that, but generally speaking, if you're exporting a piece of technology to an adversary regime, which is the ones you're most concerned about, you don't really get a say in what the use will be once it leaves your borders. And so I think the whole concept of dual use is largely outmoded and may disappear from the regulatory framework to a large extent over the next few years.
That's a great introduction to the panel that is coming up in a few minutes. Al Kapoor, thank you very much for being with us today.